Hello, this is Riley L. Peterson with my presentation assignment for Human Performance Technology Research Project. An introduction to the HPT model. HPT, Human Performance Technology, begins with an analysis, which leads to an intervention. After implementing interventions, we evaluate how effective it was. During the process, we can evaluate during each section to make adjustments that may be deemed necessary. The focus of this project is to determine how a human performance technology framework will help students better understand Newton's laws of motion in a traditional classroom. So beginning with the analysis phase, we want to analyze what do students already know, where is their comprehension at, and what do we want them to know, and then how do we fill this gap. So beginning with what students know in regard to the laws of motion, there are many misconceptions related to this topic. For example, students believe, many, that objects require a continued force in order to move. A possible reason for this is misinterpreted observations. They see a car moving, but if you let go of the gas pedal, it stops. Or if a ball is thrown into the air, comes back down, stops moving. Based on most experiences on Earth, objects stop moving if nothing is pushing them. So it seems reasonable to say, okay, well, they're not moving, so they require continued force to move. Another misconception is that size equals mass. Sometimes it does. Sometimes we look at an object, it's really big, and we think, yep, that's huge, must be very, very heavy. Obviously, not always the case. If you see a ginormous balloon, balloons are pretty light, not dense. So another possible reason for these misconceptions could be just their history in schooling, instructional methods. Maybe the teacher taught them correctly, but they never saw a good example, so they never really internalized the truth regarding the topic. So what do they need to know? They need to know Newton's laws. They need to understand that objects in motion stay in motion. They need to understand that force equals mass times acceleration, that mass does not equal size. They need to understand that when objects collide, force has an equal and opposite reaction. Every action has an equal and opposite reaction. They need to be able to predict the motion of objects in future potential scenarios and develop a deep understanding of the concepts. So, some interventions. We have environmental and individual. We're going to implement these in order to fulfill this, to deepen their understanding. First is environmental. To create an environmental intervention, we first need a clean classroom, organized space. They need tools, they need materials to learn from. A possible environmental implementation method is simulations. Simulations can be used to show how objects interact with each other. And on the individual implementation or intervention, this might be like things students are actually interacting with. So they might try to push a car and see how their force, it's very difficult, how force and their force interacts with the mass of the car versus if they were to push like a toy car or something. So implementing these interventions, first we'll have projects, then direct instruction, lastly simulations. Projects can be fun and are very diverse. We might have a rocket ship that we launch into space, or a simple rocket like this. Doesn't go very high, but kids don't care too much. The rocket launches. It's very cool. Or we've got a little motor like this that spins this sail car to help them understand how things move. Direct instruction can be boring, but still valuable. If you want to cover a lot of content really quickly, this is a good method. Or maybe we use this for giving instructions for our projects or simulations. Simulations being the last. This is one I developed. This is just a screenshot of it, but here there's a rocket ship. If you have access to this on a computer, then you can move the rocket ship. If you add any force, you can add force in any direction using arrow keys. So if you add force to the left, the rocket will just move to the left and it will never stop because there's nothing in the way. Or if you move it to the right, it'll go to the right and then it'll start to curve because there's mass right here causing gravity. So there's a force. So the object is in motion until a force interacts with it. Building on top of this simulation, we can then add other objects. Maybe we add a planet with an even larger mass. Maybe right here. So when we move our rocket ship, it goes, it sinks very quickly. And we can see, okay, mass is making a big difference here. Or maybe we collide this rocket ship with a ginormous rocket ship, and for learning purposes, we'll just say they're both indestructible. And so we can see if we launch this little rocket into the massive one is hardly going to move, and this guy's going to bounce right off and go flying. In order to evaluate, we're going to implement a formative and summative assessment. Formative assessments, there's a variety of types. This could be quizzes and tests, or just reviewing homework, assessing yourself or assessing your peers, observations from the teacher. And the summative assessment will be given. That's just a comprehensive review of everything learned. How well can they recall the information? Can they apply it to a future potential scenario? That is all. Thank you.